have students yet. Maybe one is gonna arrive on time, but I'm not sure.
Okay. In any case, if you want, you can talk a little bit about them. If you want to.
I want them to present.
Yeah, I understand. That should be the point.
Okay, I'm gonna be listening anyways.
Okay. So let's start with this new regional review. We have all the tutors from the Paris node. Okay, until I'm opening, I'm gonna share the screen. So yeah, here we go. Lorenzo, we start with you this time. Is it fine?
Who wanna talk a little bit? All right.
Okay. So I don't know. We can start with Lucia. Lucia,
Who would like to talk?
About
who is there?
You have 10 minutes. Or no. So basically, we have Jan today. So I mean, to be awesome, if you can talk with him and here.
Good.
hello.
Hello, Jan.
Hello. Okay, you hear me?
Yes.
Yes.
Okay. Hello, everyone.
Hi.
So Jan, you already introduced yourself, no? No, you never introduced yourself before.
No, not
It's
yet.
the first time that we meet you. So can you introduce yourself a little bit?
Okay, I'm Jan. I'm 40. I'm from Ajaccio in Corsica, and I am a technician. I work in performance in theater as a stage manager, sound engineer, and light creator. So I like to have a project directly connected to my work, and I wanted to build for my final project a system of machinery who can move objects on a stage theater.
Okay.
So the idea is to build something very adapted to my work. So with two different kinds of use, because in my in theater we have two different steps. The setting of the show and then the show. So and the two different uses are very important, and
what this machine is gonna do? Control the lighting, control the movement of objects, on the scene.
Is no, not for lighting, but to move objects like accessories, or it's only a concept. Maybe they can be used by very different things, small things or larger things.
Okay. And what you did in this assignment for the laser cutting? I mean, I don't know if one of the guys, the other instructors, have some comment on the project. Probably it's still at an early stage development.
What, sorry, can you repeat?
I said, I mean, it looks like it's a really early stage development, the final project, and again, it would be nice if we understand a little bit what's the idea of the strategy you're gonna follow in order to reach your final result. You know, which are the stages for the spiral development.
Des niveaux, d'étagers pour avoir et faire le produit final.
Oui.
Donc, tous les étagères, qu'est-ce qu'il y a ton idée
Oui.
pour arriver à faire le produit final. Donc, qu'est-ce
Ok.
qu'il y a, disons, l'application ou tu as besoin d'un moteur, un
Okay,
contrôleur.
excuse me, my English is not so good. Sorry. So I want to develop an application. To control the machine during the state of preparation, and to control movement with acceleration, speed, length, and then maybe brake. And after this, when the show begins, I want to make a link with a DMX link to control the machine with a control light desk.
Explain what DMX is, because people.
Oh.
Yeah, I don't know what DMX is. I was going to ask.
Oh, excuse me. DMX is a standard protocol used by light desk.
So wait. So basically, you want to have a machine that control and move objects on the scene,
Yeah.
and you also want to control the lighting on
No.
the stage, or not?
No. I want to control objects with a light desk.
Okay.
Yeah. But it's
What
very
is it?
it's very difficult to program movements with a light desk. So I want to develop an application to program different movements. Then we can just start the movements with a light desk. So one operator can control lights and move the moving objects.
Yeah.
I have to develop two different kinds of communication between the machine and the human. So an application with a wireless to program movements before the show. Then during the show, control with the DMX desk console.
I suggest to you and to Lorenzo personally to clarify the several steps for the development of this ambitious project. Okay, because I mean there are a lot of things that you want to achieve, and I strongly suggest that we point out which are the basic objectives that we can have at the stage 1, stage 2, and so on.
Yes.
Mathieu, what you?
Yeah, I have a question, Jan. Do you know of any similar applications? Is there things that exist on the market that are comparable, and what is it that they do or they do not do that your solution would do? Just to know what is the context.
No, doesn't exist machine like this, and I needed before a machine like this, and I couldn't find it. It's why I want to develop this concept.
So what is the solution now without the machine? How is it done? Is it just that you cannot do some things in some shows, or are they done in a different way, manually, or what is the machine replacing?
Generally, it's done manually.
Okay.
I think there is a big system of machinery in a big theater like opera or something like this, but it's very, very expensive systems.
Okay. It would be quite interesting if you could find information about this existing big systems, because then basically your idea would be to make something more open source and more low cost for smaller theaters, more affordable for smaller theaters. Is that correct?
Yes, but even the big machinery systems have no wireless communication. It works with a computer and specific software.
And would it be feasible, a question just to try to concentrate the scope of your project, to base your project on something that already exists and add, for one thing, the wireless control, and obviously we need to have other things that need to be added so that it will be part of Fab Academy, where you have to use the different things you learn. But is it a possibility to base the project on something that as an extension of something that exists?
Yeah, maybe, but but already exists. It's very basic, and I think I could
Okay.
build all the entire machine.
No, these are just questions, just to understand
think about it.
before it. So yeah, I need to have a closer look at what you're doing, and
Yep.
Okay, guys, let's move on. We need to also talk with the other students. So quickly for this assignment, try to be now a little bit faster in the explication. What you did? You work on an egg. Can you see my screen? The screen that I'm sharing, guys?
Not yet.
Okay. Now you see it. You
Yes.
see the screen? Okay.
Yeah.
So you laser cut one egg and then created a series of planes,
Yeah.
right? So it's a contouring exercise that you did vertically, no? Creating vertical planes.
Yes, but it is not finished yet.
I see.
Because I had some issue with Inkscape. Because there is a bug on Mac OS X, and when I copy-paste an object, it was copied like an image and not like an object. And I spent a lot of time with this issue.
Did you fix it?
No,
No,
not for now.
Okay.
Now there is like a huge lot of blogs who talks about this issue, and it's a bug inside the new version and the Mac. So I suggest Jan to explain. I mean, in the next days, what is it and how people can like figure out, or how can they like try to common.
Is there any joinery system, or those planes are gonna just stack one next to each other?
We can show. I saw you did it.
Oh yes. Well, it's not the object.
Yeah, the object.
Yeah. Okay.
I mean.
Okay. I try to begin the object. It's almost finished, but not completely. But okay, Lorenzo is.
Are you trying to slice like a 3D object? Is it what you're doing?
To slice? Excuse me. To slice like 3D object?
Yeah, 3D object. Is it what you're trying to do with that thing? It is not working.
No, it's.
Yes.
If you see the.
He was
Lorenzo?
trying to do that with Inkscape.
Yeah.
Okay. Okay. You want to do that with Inkscape, like with what? With Inkscape? What would you do that with Inkscape? Is it convenient for you, or there's other ways to do that?
Oh no, I think there are many other ways.
Okay.
Inkscape is not my favorite soft, but.
It was a part of the week, so.
I got it. Okay. I won't interfere, but you can use 123D Make to do that, for example.
Yeah, but I think 123D Make does it for you. It would be a bit outside of the scope, isn't it?
True, but I mean, depends on if you need speed or not.
Yeah, I was going to suggest OpenSCAD. for something like that, which would be an interesting.
If you have a background, like if you code already, it's interesting to use OpenSCAD. But if you don't, you're gonna suffer a little bit.
There are tutorials. Someone in Ajaccio that knows OpenSCAD, that could be interesting. Sure.
Okay, let's move to the next student. Sorry, guys, we need to see as many as possible. Lorenzo, is there anyone?
Fridtjof here again.
Okay, good.
Yeah.
Hello, everyone.
Hello.
Hello. Nice page. So, what about this week? We met last week, right?
Yes.
Okay, perfect. What about this week? How was the week?
This week, my artistic skills are much more basic than Jan's are. I'm more of an IT person. So my project was quite simple. I was just looking to create a little puzzle, much like the one that Neo presented. And the images are not, I'm almost finished. I need to cut the cardboard. That's where I'm at. And then replace the images on the web page. And then I also use the vinyl cutter to make a sticker, a vinyl sticker from some SVG artwork that was available on the internet.
Okay. And what did you make the joinery parametric or not?
No, this is something I understood parametric joinery. However, the way I looked at it is, if you look at if you will, the puzzle, you could make all those joints parametric. But the way I looked at it was more efficient to build I would say the comb that tests the different sizes, and then once I've established what the appropriate size is for the quality of cardboard we have, to just fix that value in the final drawing. Because otherwise, while the parametrics would permit you to change that on over the entire scope of the cuts that you're making, if you make an error, you have to recut everything, and this could potentially become very expensive if the material that you're cutting on isn't anything more sophisticated than cardboard.
Yeah, but you're not going to cut them one by one anyways.
You first do test.
Yeah, you can test that, sure. I just decided to do it once to come up with the right size and then design everything, because that's just a simple copy and paste. Once you have one done, then you can taste out the grid and you have all the pieces that you need.
Yeah, but the idea of creating a parametric model is that we can actually adjust the joinery according to the material itself. So if we want to cut, for instance, now with the paper and tomorrow with polypropylene or another material, we can just modify the size of the joinery and update all the components. So I see it the other way around. I mean, is the drawing that is taking the information from the material, and then of course, I mean, you just do a little test, and what you check is more or less how you say, lo sfrido. How easy is it to make them slice? So if you need to adjust a little bit or not the joinery.
I think you bring up an excellent point, and one that I had not considered, which is exactly if next we go from cardboard to MDF or acrylic, if I wanted to go back now and change the puzzle page, that would be onerous because I would have to rebuild the whole page instead of simply... Yeah.
That is the whole point of the exercise.
Yeah.
And in your case, you only have 3 pieces, so thinking of redesigning and copying and pasting because there's 3 different type of objects. It's fairly easy, but imagine that you're doing something more complex where there is 40 different kind of pieces that all depend on the thickness of the material or on some other factor. Well, parametric would be quite useful here.
Absolutely, no question.
Good. Okay, thank you, Frederick. Sorry, we need to move on, otherwise I will not have time. But in any case, I see that your page is different from last week. It's a big upgrade, right? You didn't have it like this in the previous week.
I keep working on it. It's a work in progress.
It's very neat. I really like it. It's a beautiful website. Okay, so next, we should also talk about the final project again, but not now. I guess we have some things to discuss about it. Okay. So, Lorenzo, there is anyone else there?
No, we have finished.
Okay.
We are lucky to have two. So.
Okay. It was good. Romain, someone came there in Fab Lab in Digiscope?
Yes. Yeah. Here is Andreas.
Hi everyone.
Hello.
Going to talk about his documentation and project.
Hi everyone. So my name is Andreas. I'm at the Fab Lab Digiscope. And maybe you want me to present my project or
present
talk
yourself.
about the assignment of this week? I don't know.
Introduce yourself before and talk quickly about your project as well.
So I work at the Fab Lab of the UPMC, the University Pierre and Marie Curie, where I also study. So I'm a physicist. I have a master's degree in physics. So the other half of my life I spend it in the Fab Lab, since I'm one of the Fab managers over there, working part-time, but I'm spending almost my entire day in there. Mm-hmm. So, and now I'm following the classes of the Fab Academy at Digiscope, which is a little bit far from my home, but I really enjoy coming here. Mm-hmm. And so the project, since I do a lot of physics, I always try to embed some science or some science demo in my projects. So I've been working a lot on some cymatics, showing sound in some substances, on acoustical levitation, and all other of electromagnetism demonstration that would be possible with physics. But lately I've been working a lot on a project which is called the Cloud Chamber. So it's really rudimentary particle detector that has been invented a couple of 100 years ago. But the simple concept is using real cold plate that you put underneath and some hot temperature on the bottom, and that will create a metal stable state in the chamber that allows you to detect the radioactivity. So it's not really used for research because you cannot make any measurement on it. It's only educational, and I thought it was a really cool project because it involves 3D and 2D design. It has an electrical part because I need.
Do you have sorry, it sounds super interesting. Is there any link where we can see what you're talking about?
On the website, there's the part my project, where I quickly explain what it is and what you can see in it. But I still really have to work on my webpage because I spent a lot of time learning HTML, and with Git I lost a lot of time. So now I'm trying to straightforward and present a little bit better my project and do the assignments more than spending time on the webpage. Yeah. I did that way too much in the last weeks. But to be simple, the project I want to change from the one that has been invented 100 years ago, because usually it was using dry ice, which is really hard to find, and it's complicated to obtain. So I want to replace that cold part by Peltier modules, which are thermoelectric modules that can allow me reach the needed temperature, which is minus 30 degrees. But I thought I would compose my project in two parts, because the most important is to reach minus 30 degrees Celsius. So I thought it would be cool to try to invent a mini cryogenic for a Fab Lab, because I know that usually in Fab Labs we're not interested in having cold temperatures, but in my case, in the Fab Lab where I work in the university, we're always building experiments and trying to make projects that involve actually having really cold surfaces. So I thought it could be interesting to make a cryogenic system for the Fab Lab, which be do it yourself, and then attack to do the Cloud Chamber, which will only be adding some components.
Okay. Let's try to put all this information online. So add as many links as possible, and because it's very interesting, and as you said, there is nothing like this in the Fab Lab, and it can be also interesting you know, as you said, to understand how to extract data out of it.
Absolutely, absolutely. That's what I want to make, is put sensors everywhere.
Exactly. I think that you know, move an experiment from like this, from the educational side to a scientific side, where we extract data, taking pictures and camera or videos of this process, can be very, very cool. We process a lot images, and we use the proportion and, you know, the pixel analysis from all the images in order to detect growth and this kind of process where you have, you know, I don't know, mycelium growing, so fungi or bacteria covering specific surfaces. So it can be absolutely interesting, but again, I see that it's not structured your final project like the one before in the Fab Academy way. We need to understand which are the different levels of. I'm sorry if I repeat all the time the same concept, but it's quite fundamental. It needs to be clear how we're gonna develop this project through the Fab Academy. You're gonna have at the end, Romel knows it, 2-3 weeks to close it. It's not really a project that's, you know, lasts 6 months. You will be very busy to develop electronics, and there are a lot of issues that will take your time, consume your time. So, I mean, try to understand what you can do in the early stage, and then the rest. So, and put a little bit more of documentation online, and put documentation online, because I don't think this is still enough.
Nothing for the moment. I spent so many time trying.
Don't worry. It's just a comment.
Website that I'm straining forward now.
It's very interesting, the process. For the week 3, what about this week?
So this week, the parametric design, it's something that I'd never done before. So I wanted to use a whole new program, so I downloaded Rhino and Grasshopper. I played around a little bit with it, and at the beginning I was just doing some tutorials because I didn't find the idea that would fit with my project. And finally I got on something that was pretty interesting. I thought it could be an idea to try to prototype a heatsink, because I know I got a heatsink, because the problem with my Peltier is something that makes the heat go away. Like when you put the radiator with the fan, it's metallic and it has a lot of little shapes. So I thought typically that would be a parametric design. So I knew that it would be hard to make it out of metal, but I thought it would be a good exercise just to try to make it for me. But as Grasshopper, I think I went a little bit too far in my. I've been using functions that I didn't really understand what they were doing at some point, so my design went completely crazy. But I know what the problem is but.
We can take a look at it. With Grasshopper, what I suggest is that you try to use, you avoid, at least at the beginning, try to avoid using pre-made scripts, you know? So try to understand the basic definition using native components, you know, and avoid using components that are, you know, built in Python or pre-made, you know, because otherwise you will never understand what's the logic. And actually, a very simple exercise in Grasshopper can just be do a square, you know, and then understand how to modify the joinery, you know, the dimension of the connection that you may have on all the sides. It's a very easy exercise. Can, you know, make you understand how to orient the geometry. You know, how to use this geometry in order to cut the main surface and have a final piece. Okay. In any case, yeah, I suggest that you also take a look now at the other guys for your documentation. It's missing a little bit of. It's missing all the images, and it's also missing the files that you use. So they also need to be uploaded online. So your file should be there and possible to download.
Oh, maybe. Yeah, I've done that yesterday night, so I think it might have screwed up.
For the future, don't worry. Okay, thank you.
I lost a lot of time trying to have a web page, but now I'm trying to. It's just a white blank, and I'm just adding information because I need to go on, and I can't spend so much time doing HTML because I've learned what I needed, and now I think I just need to go on and let it go.
Perfect. Okay. The others want to say something? No. Well, okay. Let's move to Paris. The students warm and volume. We're gonna start with Romain this time.
Hi.
Hello, Romain.
Hi, everybody. Yes, just I don't know. Probably everybody can see the shared page, but I cannot. I don't know for everybody. It's okay.
Do you see my screen or not?
I don't. Probably.
No, now is it
possible?
Now
I see. Yes, it's okay.
Okay.
So, right, just a little remark about the previous. I also have one of the sub-project is the Folk Chamber. So, okay, just 2 assignments this week.
Mm-hmm. Here we go. Okay,
I worked on following. I checked the different tools and I checked Antimony. I checked FreeCAD. I worked a little with Rhino. I worked a little with Inkscape. I tried QCAD, and I used the famous site that we have discussed last week, the Maker Case, just the site that permits you to create the boxes laser cutted directly. So I did my design of the box for the Folk Chamber, and so I started by this. I just tried to cut it, so you can see it's cutted. It's placed for the screen for the transparent screen, placed for the element Peltier that can make a code and so on. So then I passed to Kit to produce my kit, and I used Antimony. Antimony is
nice.
Good tool. Except the community is very hidden, or it doesn't exist. The little problem you touch, and it's a cauchemar to find the answer. You pass the days to find it, but when you find it, so my first design was, you can see it's a big program that take this polygon, that I take the square, that I resized, that I put it, then I rotate it, that I make a difference, that I rotate it, then I make a difference, and so on, so on, so on. You see a lot of steps. But then I become good in Antimony. So I did, okay, I will optimize it. So now you can see the same done in few steps. And the first step is the parameters. You just put the parameters. The parameters is the thickness of the material. And from the thickness of the materials, it's recalculate everything, and it's okay. And it's done in few steps.
Oh, nice.
So then I said, okay, let's try the different shapes. So I make a connector of the line. They make a connector in the triangle. And all files are accessible. You can click and download it. So then you can go down and you can see the results. The results, yes, we cut it. It's fantastic to work with this laser cutter. And children at home, they try to build the things with it.
Your team, no?
Yes, exactly.
No, so very well documented.
The one problem with Antimony is the few problem of Antimony is just it's probably young tool, but it's really easy to use when you understand it. And the problem is that it doesn't provide many different formats. So as a result, you can have PNG or you can have the STL. So PNG, okay, and then I take PNG, I go to Inkscape, I put it to vector, then I go to the, then I save it to the DXF, then I go to Rhino, then I load the DXF.
So from Antimony, you're getting a PNG.
Yeah, you get only PNG or STL. You can have STL, but okay, STL is for 3D. Probably I will use it when we will do the 3D printing. It can be useful. So then I go to Rhino. I make a copy paste. I make a placement for elements already ready. It takes few minutes. It's all on antimony to make a new design. When I understand how, it's really a few minutes from the start to the end.
And what do you think about the interface of antimony?
No, it's cool. It's light. It's really, it's a really geek thing. It's for geeks. It's simple. It's can the Python inside. So if you want to make, I said okay, it's 14th of February. So I think okay, I will make a shape like a heart. So I started like Python, then I said okay, yeah, another thing's more important in the life. But it's easy. It's cool. It's geek.
Nice.
But not sure that when you go in real production, it can be.
Useful. And about the 3D, let's say, generating three-dimensional shapes, did you try it, or it was always a flat?
Yeah, I tried. Of course, it's simple. It's simple as well. I'm sure that when we will do the 3D printing, I will use the antimony for this.
Oh, very nice.
Yeah.
Neil is gonna appreciate this for sure. Okay, Roman, very good documentation. I don't know if some of the structures. You can talk when you want. All of them.
No, okay. Just and I did a little bit update my primary project, as you told me last time. So I put a little bit more info. If you return back and you click the primary project, so
which one?
The first one, Oximeter Glow. So and then you click here to see the full details. So I put a little bit more information that's about why I do this project and the problems I have, the status where am I put a screenshot of my Trello, and I put for evaluation. I put the steps I do, and probably this week when we will start electronics, it will be more closer to what I need to do. So it will help to progress more.
To be honest, I really like your documentation. It's very complete, I would say.
Yeah, thank you.
Okay, moving on to our friend, probably Ludovic. Let me check who is Ludovic.
Yes, I'm here. Do you hear me? Okay.
Yes.
So, hi everybody. So let's go to my assignments. Okay. The goal was to make a press fit construction kit, so I decided to do a dodecahedron. So what is a dodecahedron? A dodecahedron is a polyhedron with 12 faces. So it's made with pentagons, because I wanted to do a regular dodecahedron. So I've wrote some blah blah about why pentagons are so interesting, because they are including golden triangle and divine proportion. I like very much.
Right.
So, nice. But it was just.
This is the blah blah.
Yes. It was for fun. Okay, so how to make it? So I've tried several software to draw a parametric shape. So I know Blender for last week. Blender I've used to modelize in 3D my project. I've tried FreeCAD. I like very much. FreeCAD is based on the constraints between every parts of shape. And
is this one?
FreeCAD.
Is this one?
No. I didn't take
you didn't upload the picture.
Yeah.
Okay.
But I suggest everybody can install and use 5 or 10 minutes of FreeCAD just to understand. For me, it's very interesting, and it's a free parametric software. So, but I wanted to improve Rhino. And I retained the Rhino for this week. And to do parametric elements, I've taken. So I didn't use Grasshopper because I'm not enough good in Rhino for the moment. But I've used the Saverio method with block methods. Thank you, Saverio, for your tutorial. So it helped me very much to draw my shape. So the shape is step 2. So I have to design the shape. So it's a pentagon. So 12 faces. I decided to join the pentagons with 2 jointures. So I have to design blocks to draw this jointure, 2 jointures per line. So I've done rounded chamfers, and my jointures is done with blocks.
So you copied the element 60 times.
Yes,
and,
with array functions.
How many of you use a nesting tool? Do you know what is it? Nest?
No. What?
Okay. Basically, you can optimize the position of the material of the drawing that you need to cut inside a panel, minimizing the area that you need to.
Yeah.
Let's say minimizing even the dimension of the panel that you need to use. So I guess this is something that you should also start to be a little bit more familiar, because it can save a lot of time for you about the positioning of the, saving time from the positioning of all these elements inside the panel, and also save a lot of material.
Okay.
So there is a tool in Rhino that is called Rhino Nest that you can use, and there are also several plugins, even free in Grasshopper, that you can use. I will share for you, share with you the one that I know.
Okay. Thank you. So the result is good for me. After the first test everything was okay. So and I made the construction, the press-fit construction kit, and my dodecahedron is here.
Yeah.
Yeah, I've done a small video.
A small dodecahedron. Okay, very nice.
Yes, it's very solid. Jointures are very okay. Maybe I don't know. It was not the goal, but maybe I can do a dodecahedron to do the head of my FabPong. Maybe, I don't know, but it could be.
Okay, absolutely, you can use this exercise to start doing some parts of your final project. Okay, Ludovic, well done. Only one comment. We just saw Romain and what he's doing for the documentation. It's quite good if we have a list of the softwares that we use at the beginning. I guess it's an interesting source. It's quite easy to detect what you did, and also I suggest to put some links to those softwares, so we can easily move there. Yeah, I also suggest to try to use Rhino Nest or other nesting programs, softwares, which will speed up. Saverio, how was the?
No, it was a good job. I have no comment.
Thank you, Saverio.
But try to learn Grasshopper as soon as you can.
Yeah, it's the next step. Absolutely.
Not that difficult.
Yes, thank you.
Parce que c'est des
Okay.
lourds.
Good. Now let's go to Thomas. It should be the last one. No, we also have Guillen. No. Okay. Thomas and then Guillen. Okay, Thomas.
Je crois qu'ils ont donné un lien pour le voir.
Yes. Hi everyone.
Non, c'était pour Autonest et pour
Guys, I think you have to shut down your mic. Thanks. So hi everyone. For this week assignment, I tried to design construction kit for both chess game and the checkers game. So, do you hear me, Saverio? Aldo?
Yes.
Okay. So first thing, I tried to use as many tools as possible for making some tests. So first of all, I made some tests with Rhino using the little features that Neil talked about. So the unroll method with Rhino. I also tried 123D Make to see how it worked. I found it was really nice. So I talked about it in my page a little bit, and then I tried to find the best way to make parametric design. And so first I wanted to use.
Lorenzo, sorry, Thomas. Lorenzo, can you turn off the? Okay, thank you. Go, Thomas.
Yeah. So first I wanted to use Inkscape and the clones methods. But I realized it was not really convenient for the job because it only duplicates things, and since I wanted to use chamfer for my joints, I had to make a block and then add the chamfer, make a group of objects, and if I wanted to then modify the width of my joints, it wasn't really working well. So I switched to Rhino and I used the Saverio method with blocks for making my joints parametrical. And then I did some tests, just designing small pieces, as you can see on the screen. So this little square and other pieces. I made some tests with cardboard, and then I designed the final pieces for my chess game and for the checkers game. So you can see it here. I tried to use the nesting method as much as I could, but it was done manually. I didn't use any specific soft for it. So first I designed the parts. So as you can see, each joint can be used either for making a chess piece or a checkers piece. So there's 3 different types of joints, and depending on the way you're mixing them, you can make a chess piece or a checkers piece. And for the board, it's a board that can. So the chess board is 8 by 8 squares. And checkers, it's 10 by 10, so I just design something that you can add to the chess board to make it checkers board using those joints.
Very, very nice. Okay, now that you all did the exercise of press fit, I'm gonna share with you some press fit that I like. I didn't want to force you in one specific direction. But this is a little collection, not so many, but things that you may start to look at. So for some press fit, not a lot of them. Some of them are also from some Fab Academy, previous Fab Academy courses. Okay, you will look at it later. It's a really small collection. Apart from this, did you also engrave on this assignment? Because you didn't only just cut; you also engraved here the squares, no?
Yes, the green lines you can see are for engraving. So
okay, so did you engrave with two different? There are 2 different engraves. That's why you have also the black one, or it's just one?
It was just because I wanted to specify the order of engraving. I wanted to first engrave the inside of the squares and then to engrave the sides of them. So I chose 2 different colors, but it's the same engraving. It's the same settings.
Okay. Okay. Good. Well done. I guess the comment here is the same. Let's put the software that you used at the beginning. I also will suggest not to stop here, but keep exploring the potential of all these tools, parametric tools more than anything, into your design intentions. As you all know, we already record 1 hour of Rhino, and we're gonna do it again since there were some problems with the Google Hangout. unfortunately. So we're gonna work twice if we do it. But hopefully, I'm also gonna add a little tutorial for the Grasshopper, which I would really like to have time to do. Okay, Guillaume, are you there? Guillaume?
Yes. Yes.
Okay. Let's see also what you did. Do you see my screen?
Yeah.
Okay. Here we go. I see that you did the negative of of Ludovic. This is a positive. You worked on the negative.
Exactly. Basically, I made a mistake on this project.
Why?
Because I wanted to do something and I had not time to finish it. So then you can see the first one was what I wanted to arrive to. And since I tried to make the joints on Grasshopper, and it was vicious and somebody helped me, but I managed to do it, but it took me a lot of time. I just arrived to one mobile axis in the middle of the dodecahedron. Like, okay, I had no time to connect the second axis and the.
I mean, your idea was to generate dodecahedron with two circular geometries inside, right?
Yeah. To have something which is either on one side, either on the other side. And it would have been positive and negative dice.
Okay.
But I just made that.
It's not a bad detail, this one. If you can implement it a little bit more.
Yeah, this was the one direction. And so basically, there's a mistake on the Grasshopper, as you can see. Sometimes there's two circles, sometimes there's just one. So I think it's I think it's the geometry, maybe.
Why are you having this problem? This is generated by Grasshopper?
Yeah.
Okay. How are you working with the lines? I mean, are you working with the wireframe of the geometry? No?
Yeah, I started with drawing the volume of the dodecahedron.
Okay.
And starting from there, isolating the arrays and the edges and the vertices. And by that, I make some plans on every corner with the center. And then I can scale the depth every joint. There's also, you see the beams. You've got to make a smaller beam at first to make the first Boolean operation in the circle, and then a second Boolean operation to have your half-half joint.
But how is it working with the circle with the three connections? Because
it's working quite okay.
It's working quite okay, right? Because in theory, I mean, all these three directions should meet in one unique plane. You know, otherwise you need to have a folded joint.
But if you look, there's an angle on the joint on the beams part. So yeah, it's working all right.
Okay, good. Regarding this problem that you have here, it can be an overlap of points that you have there in this specific intersection. There is a command that is called cal duplicates.
Yeah.
In Grasshopper, and can allow you to erase duplicated points. Because if you are working with wireframes, every line has a starting and end point. No?
Yeah. Yeah.
And all these points, all these lines actually are duplicating their end and final points on top of the next one. So you need to be sure that you only have the number of points that is the same of the vertices of your pentagon. Okay, of your entire figure.
It was a bit messy at the beginning.
Okay. It's not so easy. So don't feel frustrated. I lost an entire night calculating a connection.
Clément told me that it's normal to be disappointed, but that I'll be disappointed always, but that my work will be better from time to as time goes by, and I believe it's true. That you always want to make more.
It's okay. Okay. Did you upload also the file for the?
I just get how to do that. I asked somebody at the class this afternoon.
Okay.
Bye.
Okay, guys. Thank you, Kian.
Thank you, Pablo.
Okay, I will say that Lorenzo, final comment to close the regional review.
Well, to be honest, I think all of the projects are really, all the students are getting better. I like your idea to put on the top of each module, like each software, the name of each software, and the fact that most of the students are really trying to figure out to solve some problems, some issues with different software. The next software you talked about before, there is a student of mine, he's called Gerard Bandini. He used it, you can see in his page.
Okay, one second, I'm gonna go there.
Yeah, in the week number 3. A lot of work also, and especially apart from the clone tool, he used also the SVG Nest.
Is it open source?
Pew, that is the sound of the laser. Yes, so.
Sorry, Lore, I didn't understand. Is it open source, the SVG Nest?
I just upload this file. I thought it's open source because he worked with Inkscape and used it, and he did some tests and.
Open source vector nesting. This is very awesome. It's super nice. Can you see the screen?
Yes.
Yeah, I never use it.
Yeah, it works really good. I mean, as you can see from his pictures, it's not really well made.
Very nice. Thomas, can you see what I was telling you? No, it's automatically positioning all the geometries, and you can see actually also how much material it's saving. It's super useful. Okay, I suggest to all of you, in general, to add all the links and suggestions that you are receiving during the regional review to the documentation of your page, because this is at the end the main reason we are all doing it, this review all together. Okay, Romain, did you know this one before, the SVG Nest?
I heard about it, but I never used it.
I did.
What?
Yeah, it's like someone mentioned it like a few weeks ago, I think. I recently discovered.
Very nice. Okay.
Last thing I would like to say, maybe, I don't know, it would be interesting to see if any one of you guys has played with engraved from and different materials apart from cardboard. Could be interesting to know the settings that you used in order to see the different texture, that the frequency or the power, the speed. That could be.
Yeah, actually, Lorenzo, if you allow me to complete something, we have a very small app that is excessively simple. You can use to put all the settings you've been using during laser cutting and 3D printing. It's called Fab Doc Maker. It's on the FabLab Digiscope website. I can send it to you.
Yes,
please. Very interesting.
Fab Doc Maker. There is a GitHub. Fab Doc Maker. Like that. And I mean, if someone is wants to develop, like, to make a new form for the machine you have, because our form is based on the Epilogue 40 watts. If you want to make a new form, we could ask the person to integrate it, so you could get your form in the new version of FabDoc Maker. You're gonna understand better what I'm talking about once you use it.
Okay. But basically, you can save all the settings of your laser cut.
And then it makes a PDF. You can include pictures inside.
Oh, that's amazing, huh?
Yeah. I think we could make a good use of it. So it's going. My idea was to standardize the way we could document and share the processes, and I want to integrate as many machines as we can. You see, like the Roland and whatever. But since at the beginning I didn't have a lot of feedback, you know, I made the workshop on that thing at MIT when we were there. Yeah, you remember that? And I had like probably 12 people, and then I started to spread a bit, but like people didn't really answer. So now maybe if you feel
well,
like
we can use it. At least you know the friends note, we can use it, no? We can try to ask the students to fill it and create more documentation even for you.
I used it for how to grow most anything, for a few things. I mean, at least I like it.
I think it's very useful. Thank you, man. This is a very good tip. So, yeah, I'm sharing the link on our chat. Okay. Did you also share this one with the rest of people in the academy, with the other instructors?
I did that. We didn't start Fab Academy yet, so it was a few months ago. I'm gonna do it today. I will send it to Instruct and class.
Okay. Super.
Sure.
Thank you, guys. Okay. I guess now it's 1 hour. We can close the regional review. Thank you, everybody. I'm uploading all the regional review online directly, so for the others that are missing it, it's all recorded online, and I will put them in our page. Okay? So, thank you, and see you later.
Ci vediamo.
Grazie. Ciao.
Ciao.